Well, just when you thought we had mastered everything possible about composition of functions, there's one more thing I'd like to talk about. There's actually a lot more, but I think the discussion we've had so far gives us a good overview of finding functions from an equation perspective. Another thing that could be explored could even be more of a graphical perspective. But what I'd like to look at in this video is, let's say we were given a function that's the result of a composition. So I'm going to call this, just for ease, big H of x. And I'm going to assume that this big H of x is the result of composing functions f and g. So let's say that H of x is equal to the square root of, how about 3 minus x squared? And what I'd like to do with us all now is determine a possible f and g. And I'm wording it that way because sometimes with problems like this, there's more than one possible solution. So let's determine a possible f of x and g of x if we know that h of x is the result of composing f and g. So we're kind of working it backwards, and that's something that in math is pretty fun to do, to be given a solution and then work it in reverse. So we're trying to figure out what could f have been and what could g have been, so that when we do the composition, we get the square root of 3 minus x squared. Sometimes with these, I just have to play around a little bit and actually try the composition in the forwards direction to see if it works. So just to kind of reiterate our goal, we want to know what is a possible f and what is a possible g, such that if we take f of g of x, we arrive at this radical function. So h of x is the result of composing. So sometimes with compositions, you'll hear folks talk about inner and outer functions. So in this composition, f of g, right, it's kind of like f is what we could call the outer function. So when I look at the square root of 3 minus x squared, I feel like the outer piece, so to speak, could be expressed as the square root, whereas the inner piece is the quantity underneath the square root. So let's just try letting f be a general square root. So I'll just say square root of x. And let's try letting g be the quantity under the radical, 3 minus x squared. Now that we've tried, again, just picking an f and a g, we might be right, we might not. Let's just try working that composition out forwards now. So let's try f of g of x based on the choices we just made. So that says start at function f, which is a radical. But then anytime you see an x, which is right underneath the radical, stick in function g, which is 3 minus x squared. And that looks exactly like what we found our h of x to be at the beginning, right? We were given this h of x function. So that seems to work. Now that may have seemed kind of easy to walk through together. That doesn't mean problems of this sort are easy. So feel free to just take some time, make a guess at f, make a guess at g, work it out and see if you're right. So these are kind of puzzly problems. Since we found f and g successfully, again, the goal here was find an f and a g. We did. So this would be our solution for f. This would be our solution for g. But let's just take a minute and ask ourselves about the domain of h of x, just because domain can be one of the more confusing aspects of functions actually in general. So let's just end this video by looking at the domain for fun. So what is the domain of h of x equals the square root of 3 minus x squared? So when you have a radical, right, we want to make sure all the values, more specifically when we have a square root, we want to make sure all the values under the square root are positive or 0, because the square root of a negative number is imaginary, it's non-real. So in order to find the domain with square roots, we've seen this before, a common technique is to snag the value under the square root and set it to be greater than or equal to 0. So then we have to solve that resulting inequality, and this inequality looks a little strange. I'm going to start by adding x squared to both sides. And then I'm basically going to be square rooting both sides, but I'm going to end up with like a plus or minus, right? Because when we square root, we get a plus and a minus. So what I'm going to try out with you guys, just to see if this makes a little bit more sense. I know square rooting both sides, I would get plus or minus the square root of 3. And what that does on our number line is it actually creates 3 intervals of space, right? So the possibilities could be one of the two. The domain could be all the stuff on either side of those positive and negative square roots, or the domain could be all the stuff in the middle. And what I prefer to do is use test values to determine which of those two possibilities is accurate. So from the inequality that 3 was greater than or equal to x squared, we square rooted both sides to get the plus or minus square root of 3. And then I'm just going to pick a test value to determine which interval or intervals are true. An easy test value to me looks like 0 because I can tell 0 is smack dab in the middle of these two negative and positive radical 3's. So if I test x equals 0, that means is 3 greater than or equal to 0 squared, which is 0? Is that a true or a false statement? So is 3 greater than or equal to 0? Yes, so that's true. So because that's true, that means it's the interval in between these radicals that the domain can accept. If I had chosen, just for the sake of example, a test value outside of that interval, so the square root of 3 is a decimal, right? It's something in between 1 and 2, I guess, right? So let's say I had tested x equals 2, which I know falls on this side of the square root of 3. Then I would have gotten that 3 is greater than or equal to 2 squared, right? Because it's x squared, which is 4, and 3 is not greater than or equal to 4. So I would know this interval over here is false. I'll leave it to you to establish that the interval over here is likewise false. So the domain is the values that do satisfy the inequality. So I'm going to express the domain of h of x then as set builder notation and interval notation. We'll try both. So I could say all values of x such that x falls in between negative and positive square root of 3. Or for the folks that prefer interval notation, that's just described as negative square root of 3 to square root of 3 with brackets because the square root 3 values are allowed to be included. So anyways, that's a little bit more about compositions, perhaps more than you ever thought you'd talk about compositions, but I hope that helps you feel a little bit more comfortable.